All right, so today we're going to tackle a really cool skill, writing equations for perpendicular lines. This is kind of where everything we've been working on, finding slopes, using point-slope form, it all clicks together to solve one awesome new kind of puzzle. Let's dive in.
So here's our game plan. First, we'll lay out the basic challenge. Then, I'm going to let you in on a super simple secret for finding perpendicular slopes. After that, we'll jump into some examples, I'll point out a couple of common mistakes to watch out for, and finally, we'll see where this math actually pops up in the real world.
Just like with parallel lines, we're going to need two things to get started: a line to work with and a point. But here's the big twist. With parallel lines, we just stole the slope, right? Easy. For perpendicular lines, we have to totally transform that original slope into its perfect 90-degree partner.
And that's really the big question for today. We're not just looking for any line that crosses our original one. Nope, we are hunting for that one, single, unique line that goes through our specific point and makes a perfect right angle. It's all about precision.
So, how do we actually do that transformation? Well, this brings us to the core technique, which is honestly like a secret weapon for this whole topic. It's a simple, easy-to-remember method that I call the flip and switch.
Now, the official fancy math term for this is the negative reciprocal. I know, it sounds a little intimidating, but really it's just a formal way of saying you do two things. You take the slope, flip it upside down, and then you change the sign. That's it.
Okay, check this out. Let's say our original slope is 2. And remember, any whole number is really just that number over 1, right? So we have 2 over 1. First, we flip the fraction. 2 over 1 becomes 1 over 2. Easy. Then we switch the sign. It was positive, so now it's negative. Our brand new perpendicular slope is negative 1/2. Flip and switch. It's seriously that simple.
Okay, theory's one thing, but let's put this into practice. We're going to run through 3 different examples, starting simple and working our way up. By the end of this, the flip and switch method is going to feel like second nature.
All right, here we go, problem number 1. We need a line that's perpendicular to y equals 3x plus 1, and it has to pass through the point 6, 2. So, first things first, what's our starting slope?
Well, in y equals 3x plus 1, the slope is clearly 3, or 3 over 1. Time to flip and switch. We flip 3 over 1 to get 1 over 3, then we switch the sign from positive to negative. Bam! Our new slope is negative 1/3. Now we just grab our point-slope formula, plug in our new slope and our point 6, 2, and we get y minus 2 equals negative 1/3 times x minus 6. Perfect!
Okay, next up. This one's a little different. See how the equation is in standard form? It's not solved for y. So, what's our first move? Before we can even think about flipping or switching anything, we've got to find that original slope. And that means we need to get y all by itself.
So, we do a little algebra on 2x plus 5y equals 10, move things around, and we find out our old slope is negative 2/5. Now we use our rule. We flip negative 2/5, which gives us 5/2. Then, we switch the sign from negative to positive, so our new slope is a positive 5/2. Last step, plug it all into the point-slope formula with our point 2, 4, and we get y minus 4 equals 5/2 times x minus 2. Nicely done.
All right, our last example. This one looks super simple, but it's got a really cool little twist. The line is y equals 4. So, what kind of line is that? Just picture it. It's a perfectly flat horizontal line. Now, what does a line that's perpendicular to that have to look like?
Exactly. It has to be a perfectly straight up and down vertical line. Think about it. The slope of a horizontal line is 0. If you try to flip 0, which is like 0 over 1, you get 1 over 0. And what happens when you divide by 0? Yeah, you can't. It's undefined. This is a special case. The equation for a vertical line is always just x equals a number. And since our line has to go through the point 5, 2, it has to hit the x value of 5. So the equation is simply x equals 5. That's it.
Okay, before we finish up, let's talk about a couple of common traps people fall into. They're really easy mistakes to make, but once you know what to look for, you'll be able to dodge them no problem.
Okay, the number one biggest mistake I see is people only doing half the job. They'll see a slope of 3, remember the switch part, and just write down negative 3. But that's not perpendicular. You've got to remember both steps. You have to flip the fraction and switch the sign. So a slope of 3 becomes negative 1/3.
The other little hang-up is getting confused with negative signs. If your starting slope is already negative, like negative 2/5, the switch just makes the new one positive. You flip it to 5/2, and that's it. It's positive now. No need to write weird things like a negative times a negative fraction. Just keep it simple.
So, we've nailed the math. But I know what you're thinking. When am I ever going to use this? Well, let's connect what we've learned to something really powerful in the real world.
In physics, there's a concept called the normal force. It's basically the pushback you get from any surface. It's what keeps your coffee cup from falling right through your desk. And here's the cool part. By definition, that force is always perpendicular to the surface. So, if you're an engineer designing a ramp, you don't just care about the slope of the ramp, you absolutely have to calculate the line perpendicular to it to understand crucial forces like friction and gravity. This isn't just a math problem, it's how we build things that work.
So the next time you see a building, or a car on a hill, or even just a picture hanging on a wall, remember the hidden math that's holding it all together. These perpendicular forces are literally everywhere. The real question is, where are you going to spot them next?